moved it across. You can draw just one line or use your pencil to drag it across. If your pencil hits this graph more than once in any place, it is not a function. For here, we only hit the graph once. We hit it once there, we hit it once here. We're not hitting it multiple times, so this is a function. This graph, same idea. We draw a vertical line, and we hit this graph twice, once there and once there. So this is not a function. Now, I encourage you to drag your pencil across to make sure, because if you just drew the line right here, you see it hits just once, but as you drag it across, it hits twice, and twice all the way through. Okay, next graph. I can draw a vertical line anywhere on here, just here for safety's sake. I hit this graph once, and only once, and I can move it across and it's only going to hit once. So this is a function. Couple more examples, just to make sure you got the hang of it. You could pause the video to see if you could guess which ones are functions and which ones are not. I'm going to go ahead and do this. This one is indeed a function. I can drag this along, and so I'm going to hit the graph once. So this is a function. This circle is not a function. Hit twice, not a function. This graph is of the absolute value function, and it is a function. That's the gist of that. So, just as mappings, relations can be represented in different ways, a function can be represented in different ways. Well, let's use this general function. F of x equals 1/2 x squared minus 1. So, this first representation is an equation. We can take this equation and make a table out of it, just like the mapping, except here we have to pick values and plug them in for x and see where it would equal. So that was kind of a mouthful there. I'm going to just pick a couple values, -2 for x, 0 for x, and +2 for x. Now, when I plug this in, I want to replace my x with whatever values here. So 1/2, -2, I'm squaring it, and subtract 1. So I get 1/2, -2 squared is -2 times -2, which is +4, minus 1. Go on with that. Order of operations, I need to multiply before I can subtract. So 1/2 of 4 is 2, minus 1. And then one more step. So this is 2 minus 1, which is just 1. So -2 goes to 1. Same thing. 1/2. Plug in 0 for x. Square it and subtract 1. So I'll get 1/2. And 0 squared is 0 times 0, which is just 0, minus 1. And then multiplication before subtraction. So 1/2 of 0 is still going to be 0, minus 1, which is going to be -1. last one, 1/2. Plug in 2 for x. Square minus what? So 1/2, or I'm sorry, 2 squared is 2 times 2, which is also 4. And hopefully you're getting the hang of this. 1/2 times 4 is going to come before subtraction, which is going to be 2 minus 1, which is 1. Make the table look a little nicer. Got my x values, got my y values. -2, 0, 2, 1, -1, 1. So this is the table. We got an equation, we have a table, we can do mapping, which is easy to do that right now. Mapping. So this is my domain. My x values are my domain. Whoops. And this is my range. Take my x values, -2, 0, 2. Take my y values, 1, -1. Now, I have 1 popping up twice. We do not need to write it twice. Same with 2's. If multiple numbers show up, if one number shows up multiple times, you don't need to list it every single time. Just list it once. That's good enough. And then you map. -2 goes to 1. 0 goes to -1. 2 goes to 1 as well. Alright, the last way to represent this is with a sweet graph. And when you're graphing functions, always do a table of values. It just really helps life if you do a table of values. You have your x-axis, you have your y-axis. Put some points on there. We're going to go out 3, 1, 2, 3, back 3, 1, 2, 3. These are negatives. Go up 1, 2, 3. Go down 1, 2, 3. -3, -2, -1. It's getting a little crowded. 1, 2, and 3. And plot these points. So, using my table of values, -2 goes to +1. -2 goes to +1. 0 goes to -1. 0, -1. And +2 goes to 1. And connect the dots. So we have a sweet line. Or in this case, a sweet curve. Try and round it out as much as you can. Alright. That's it. Graphically, you can see that this is a function because you can draw a vertical line and it will pass the test. Mapping-wise, you can see it's a function because everything in the domain only touches one thing in the range. -2 goes to 1. 2 also goes to 1. That's cool. That's okay. Let's see. What else?